We have this square frame and we have a magnetic field that is parallel to the plane of the frame. So when you displace this square frame a little bit, we need to find the time interval after which the amplitude of the frame's deviation angle decreases e-fold. We are given the dimensions of the frame, the value of B, moment of inertia of the frame, and resistance of this wire. So to solve this problem, you must know two things: that flux is given by B dot A through any loop, and the current through the loop due to the flux change is given by 1 by R d phi by dt. So current is given by phi dot by R. And second thing is the torque in a current carrying in a current carrying loop, which is kept in a magnetic field, is given by mu cross P, where mu is I into area vector. So we should know those things and then we can solve the problem. So let's say we turn this frame by an angle theta. So let's say this is the A vector before and the new A vector will be here. Now we'll be dealing in magnitudes of the torque, so it doesn't matter which direction you take the A. Because we know that due to the current flow and due to the elastic nature of the thread, both the torques will be resistive in nature. So we know that. So that's why let's put the magnitudes first, and eventually we'll put the N1 and N2 with negative signs. So resistive torque calculation due to the induced current. So flux is B dot A. So we have turned by an angle theta. So B dot A will be BA cos 90 plus theta. That is approximated to minus BA theta. Now current is 1 by R d phi by dt. So we do that, and that will be A theta dot by R. Let me just remove this minus sign so there is no confusion about the direction of the current. Or okay, let me just put the minus sign here. It doesn't matter. So this negative sign just indicates that current will be induced so that this change in flux is opposed. So all those details you must have read in the chapter of electromagnetic induction. So let's just see the magnitude of current. So that is BA theta dot by R. So in this diagram, we have taken this direction of theta as positive. So outward of the plane is positive. So the torque due to the current will be mu cross B. So mu is IA. So this is I into A cross B. So A and B are making an angle 90 plus theta. So this becomes AB sine 90 plus theta, which will be cos theta. So let's just write it as AB. And I will write it this. So that magnitude of N2 will be BA by R theta dot into AB. That is this. Now restoring torque due to the elastic nature of the thread, that will be C theta. And that also will be inside the plane. So if you're turning in anti-clockwise manner, then due to the elastic nature of the thread, the restoring torque will be in clockwise manner. That will be inside the plane, hence it should be negative, but we are just writing the magnitudes. So both these torques are inside the plane, but our theta we have taken in this direction. So let's write our torque equation now. So for the whole frame, torque is equal to I alpha. So the torque will be minus magnitude N1 minus magnitude N2, that will be this. So alpha is theta double dot. So we get our standard damped SHM equation, theta double dot plus 2 beta times theta dot plus C theta is equal to 0. Now C here is omega naught square, but we don't need to bother about that. We only need to find the value of beta, because they are asking after how much time interval the angle reduces E-fold. So we don't need to worry about omega, we only need to worry about beta, because angle reduced depends on amplitude, and amplitude doesn't have a term of omega naught. So from here, the coefficient of theta dot is 2 beta. So this term is, half of this term is beta. Now we know at amplitude is a naught e raised to power minus beta t. So let's say after tau time, amplitude reduces e times. That is given to us. So amplitude becomes a by e when time becomes t plus tau. So we divide both the equations. So we get E is equal to e raised to power beta tau. So we take ln both sides. So tau is equal to 1 by beta. So we put the value of beta here, and this will be our answer. All right.